Hello, good to have you on this channel. So today I want to talk about length of arc, perimeter of sector, and that of segment. Before we go into it, let's look at some important concepts or things worthy of note before we dive so deep into it. Okay, this is circle, and if you have a line like this is called a chord. Okay, so this is a chord. A chord is any line joining two parts of the circumference but not passing through the center. So when it passes through center, it's a special chord that we call diameter. Okay, so a chord divides the circle into two segments, the major segment and the minor segment. Okay, minor segment. Then we also have that's from here. Can you see? Like this. That's the minor segment. And from here up this way is the major segment. Meanwhile, if you look down the segment, you have an arc. Okay, this place, this is the arc. This is minor arc. Okay, and we have then again, if you have the circle, sorry, again, center this, and you have something like this. Those of us that love pizza, this thing looks like the pizza. So if you have it like this has to touch it. Okay, so this is called a sector. This like this up to this point. Okay, it's a sector. This is called a sector. Okay, so don't forget, still in sector we have that segment, but this is because this is a chord. This is a chord here. This is a chord here. Can you see? This place is a chord. Then this is radius. Radius is any line from the center of a circle to any part of the circumference. That's radius. So the whole of this is a sector. So in that sector, you discover that you have a triangle, you have the chord, and you have the arc. Okay. So if we at the center here, we have an angle, say theta. So what's the formula for calculating length of arc? Length of that arc. Okay, length of this arc here, length of this arc. Okay, we have to know the angle subtended at the center by the arc. Like I said, let's say it's theta. Okay, so it becomes theta over 360 multiplied by 2 pi r, where r is the radius. Where r is the radius. And that's formula for the length of arc. For example, let's say we have this question: an arc of circle subtends angle 30 degrees at the center of a circle, radius 5 centimeter. Okay, what is the length of the arc? What is the length of the arc? Okay, let's say we have to calculate that. So we apply this formula: length of arc equals this formula. In this case, our theta is 30 over 360 multiplied by 2 multiplied by 22 over 7, which is the value for pi. Then there are times they will ask us to give our answer in form of pi, or you may be given pi as 3.142. Whatever the case is, you should stick to it. Okay, so we have that. Let's see. That means we have to, so you can see we have 30 over 360 times 2 times 22 times 5 all over 360 multiply by 7 at the denominator. So if we use our calculator to do the maths, we'll see what that gives us. Of course, 30 times 2 is 16. 60 times 22 times 5. And that will give us 6,600 all over 360 times 7. And that will give us 2,520. So 6,600 divided by 2,520. What would that give us? That give us 2.6190 approximately to one place of decimal. That's 2.6 meter. That's the was it giving me meter? No, centimeter. Okay, so that's the length of the arc. All right. So then what if we are to calculate the perimeter of the sector? Perimeter of sector. So I would like to ask, what is perimeter? Perimeter is distance round an object. Distance round an object. So if you look at that, distance around that sector is radius plus radius here plus radius here, then plus this arc plus length of arc. Okay, so perimeter of a sector becomes 2r plus length of arc. All right, so that's that. Join me again for further example and how to get the perimeter of a segment, as well as from there we'll move to how to get area of sector and other things associated with that. Thank you.